And I am live, and we will just continue looking into the settings of my Wi-Fi, and my IPv6 is visible and IPv4 and MAC address. And I suppose this MAC address belongs to the NIC, that is Network Interface Controller, inside my router, and IPv4 and IPv6. I actually do not understand how IPv4 and IPv6 work. It is interesting. So do I want to get into the weeds? Uh, but first of all, let me get a overview of how things are happening. DMS, what is DMS? Okay. So in the last stream, I started looking up what this section of this means, and it turns out that my router and even my mouse and even my keyboard and even a type C to type USB adapter is a computer, a little computer with a microcontroller and memory and stuff inside, which is just crazy. So this much, uh, yeah, let's see. This is the main, and now I'm logged on. I want to explore how this works so that what is my end goal? End goal is to make my IP somehow global. I can use SSH tunneling, or this is the firmware. All right, this is the firmware, and this is the serial number for it. 2019. Yep. Content filtering is off. Home secure is not secure. Firewall always allow. Security mode WP2. Okay, so that is not very secure when I firewall is always allowing everything. And WAN, wide area network, which is the widest area network, is the whole internet. WAN is a group of some local area networks, and yeah, that is it. A group of local area networks. Here is the IPv4 and IPv6 for my router. For WAN, which would mean, wait, do I have different addresses for IPv4 and IPv6? Wait, for LAN and WAN. Yeah, I guess, yeah. When LAN, these addresses are local and local. Yep, DHCP state is also on MAC address. In LAN, addresses are local. This address refers to my router and can only be reached if a device is connected in the LAN. But in WAN, this device can be reached by any device which is connected to a LAN, and that LAN should be connected to this WAN. In that case, this IPv4 address must be the IP for my router, and the WAN is the internet here, I suppose. This one, FE80, that seems like a local thing, and this one, IPv6, let me see, can I send some requests to it? If I were to term ping http this and unknown host. Okay, and what is this? 128 at the end. Yeah, 128 slash 128. Why would I need a slash? Okay, NAT is network address translation. It only works for IPv4. Okay, that is some local address is translated into a global request sent by a device on the local network to the internet, and that is translated into the Wi-Fi's WAN IP and sent through the Wi-Fi through my Wi-Fi router as the client to send that request. And when a response comes, that NAT table is used to see to which device does this response belongs to, and the response is securely sent to that device, and that is enabled and only works for IPv4. Okay, IPv4 connection type DHCP. If I connect by IPv4, then there is an automatic DHCP, that is dynamic host control configuration protocol, which runs on port 67 on the host side and on port 68 on the client side. Then IPv4 connection type is stateful, which I did, and I forgot what stateful means. I will look into it. And IPv4 connection state connected, IPv6 connection state connected, GPON state 05. Okay, I don't know what GPON means. IPv4 gateway, that is the address that I would. Okay, so this is local. Gateway addresses are local addresses. Yep. So if I were to do this ping, this would. Oh shit! This does work. This does fucking work. Okay, if but this uh, that I get is not a local address, but how is this? I suppose is a local address because in IPv6 local addresses begin by FE80. Nope, stop. Yep, that is a local address. That is why it does not work here. 64 bytes from this. All right, and this. Let me go to projects. Projects YouTube stuff and client.c. In this, the address I will use, and fuck, I will have to switch. Fucking hell. If I want to send, yeah, I can use Postman instead of my program. Yep, let's see. And I don't even know what I'm trying to do here, but let's just, that shouldn't work. Yep, that should not work. Colon slash slash, and this, that also, yep, does not work, but it works in ping. How does it work when I'm sending it on ping? Is it because of protocol? Um, Ping and just the IP. That does work. Ping and IP does work, but it does not work in this case. What is the kind of request that ping sends? Let's see. Uh, I'll run my server, my own server. Uh, project YouTube and server.c, and the port is 80, and yep, that is cool. Server and listening on port 80, and the address. Yep, we have the address, which is if config in0 grep inet 6. Let's see, the address is secure, copied, and scope ID. And why is this dynamic? Why does it say dynamic? Hmm. Why does it say dynamic? Hmm. It will keep changing, but I said that it should not be dynamic, that it should be stateful and stuff. Yep. Ping this on 80. Right, that does not work. If I go to Postman and do http colon slash slash brackets like that, and now I do get a response, but on ping I do not get a response. But I do get a response when I I'm sending a request to my network gateway address. Hmm. Hmm. IP4 DNS secondary primary DNS for IP4 is this. Let's ping that, ping this, and got this much. Okay, not a curl. That does not work. Right. Okay, let me do curl for this URL. Mhm. Curl for this thing. Yep, that does work. Yep, that does work. Hmm. Gpon. And what does stateful mean? Yeah, what is stateful? And what is IPv4? What is IPv4 and IPv6? Let's see. Amazon services, AWS, difference between the internet protocol servers. Let's see. With the gist and explainer. Uh-huh. I can use AI to explain it to me. No, thanks. And wait a minute. Hmm. And I'm back, as you can see, I suppose. Yes, IPv4 and IPv6. What is the difference and what they actually are? IPv4 and IPv6 are two versions of the internet protocol. Two versions of the internet protocol. Oh, IPv4 and IPv6. That just shit, fucking hell. That is just IP. That is the IP protocol. V4 is the fourth version. V6 is the sixth version. How can I be this is stupid to not see it? These are two versions of the same protocol. I earlier thought that IPv4 just uses like lesser amount of bits to represent an address, and IPv6 uses more amount of bits, and that is all there is. But fucking hell, these are two versions of the same protocol. Internet Protocol addressing system, and IP is a addressing system. IP is a set of communication rules that provide data exchange over the internet. At its core, the internet is a collection of billions of devices that share data between each other through networking technologies. IP uses a numbering system to give every connected device a unique identification number of or address. Okay, that is not exactly true, because we can have any cast in CDN networks in which multiple devices have the same address. So they have manipulated it a bit, but yeah, this is like a black box, and this is how it works. It is supposed to work, and it is not exactly that the device has an address. It is has an address. It is that the interface that the device is using to connect to the network has an address. IPv4 uses 32-bit address format and can accommodate more than 4 billion address spaces. With the expansion of the internet and Internet of Things systems, which is like a lot of things, IPv4 is providing to be insufficient in its addressing range. It is being phased out by IPv6, which uses a 128-bit address format that is overkill and can accommodate more than 10 to the power 36 addresses. That is a gargantuan number. What are the similarities between IPv4 and IPv6? The main function of both IPv4 and IPv6 is to send. Wait a minute, can I turn this into black and white mode? Fucking hell. It just does not work. The main function of both IPv4 and IPv6 is to send and receive data across the internet, routed to correct devices independent of the underlying network infrastructure. Routed to the correct devices independent of the underlying network infrastructure. Okay, independent of the underlying network infrastructure, the routing or packet flow identification is the primary technology behind all internet communication. The following sections describe some similarities. Designing designated naming system. Much like each country in the world has a unique name, IPv4 and IPv6 are designed to be a way to uniquely name or identify every device on the internet. This includes computers, mobile phones, and IoT network devices. Core protocol. Both IPv4 and IPv6 are part of the Transmission Control Protocol (TCP/IP), a suite of protocols. Okay, TCP/IP is a suite of protocols. These protocols govern the standard operating framework for the internet since 1980s. The TCP/IP suite also includes the user UDP. UDP is another protocol, user datagram protocol. Despite its IP version 4 name, IPv4 was the first internet protocol. Okay, even though it was called V4 version 4, it was the first protocol. Similarly, IPv6 was first specified in 1995. However, it was not published as an internet standard or part of the TCP/IP suite until 2017. That is pretty recent. Connectionless data transmission. IPv4 and IPv6 are connectionless protocols that use multiple packet routing to break data into smaller blocks and send across the internet. IPv4 and IPv6 determine the path of each of these path the path each of these packets take, remaining meaning packets from the same piece of data may take different internet traffic routes across the internet. Packets are reassembled in the correct order on the receiving device. This is done by TCP, Transmission Control Protocol, or UDP, User Datagram Protocol. TCP or UDP, not and or. It is either TCP or either UDP. at the transport layer. At the transport layer, yep, of the OSI model. I will have to get familiar with the OSI model. Key differences between IPv4 and IPv6. The IPv4 and IPv6 packets are composed differently, with IPv6 having different headers and a shorter header space overall. Okay, IPv6 having different headers and a shorter overall header space. Okay, also IPv6 also offers separate header packets as a feature to extend routing options. The following are the three main differences from user perspective. Address space, right? The full address space of IPv4 is 2 to the power 32, or about 4 billion addresses. In IPv6 has a sufficiently larger address space of 2 to the power 128, or 10 to the power 38, or this much unique IP addresses. That number in English translates to 340, 340 undecillion, 300 decillion of IPv4 internet addresses. There are around 588 million reserved IP addresses. Okay, among the 4 billion, 588 million are reserved, which with the rest publicly available. Due to expansion of the internet devices, unallocated IPv4 and internet addresses became exhausted in 2011. While IPv6 solves this exhausted address space, the current fix is abstraction other by layering other addressing systems such as network address translation on top of IPv4 and network address translation. This works at router, but does it only work on the default gateway, or on every router that is connected in the internet? Right, that is one question, and another is the OSM. I will cover the OSI model on my own offline, because I want to see how that works. I want to spend some time on that. IPv6 also has a large number of reserved IP addresses, right? However, with a much larger address space overall, this is not significant number in comparison. Given current estimates, the space is inexhaustible. Of course, you cannot have 340 undecillion and 300 decillion address. You cannot exhaust that much. Naming. In IPv4, the address name is separated by a numeric address of 4 decimal numbers. In IPv4, the address name is represented by a numeric address of 4 decimal numbers in range of this. Okay, 4 decimal numbers ranging from 0 to 255. 255 as means 8 bytes, and yep, 8, 8, 8, 8, each representing, yep. And in IPv6, the address name is represented by 8 hexadecimal numbers made up of 0 to 9 and A to F, each representing 4 bits. So, yep, each hexadecimal character represents 4 bits, and yeah, like this, represented by 8 hexadecimal numbers. In total, there are 8 hexadecimal numbers. 8 hexadecimal numbers. 8 hexadecimal numbers made up of these, each representing 4 bits. Wait, how much would I need? One hexadecimal number can represent 4 bits, and I have 128 bits. So 128 by 4, 64, 32. In total I need 32 hexadecimal numbers. But it is saying that I am using 8 hexadecimal numbers. That means in one group I am using 8, and in total I would use 4 groups, which this seems to be it. 1, 2, 3, 4, But nope, the 8 hexadecimal numbers. In total, I need 32 hexadecimal numbers. 8, yep, I would need 4 such groups of 8 hexad. In total, there are 1, 2, 3, 4, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. That is 16, that is not 32. And in this, there are two semicolons and nothing in between. So I guess that would be 0, considered 0, or maybe all the 4 hexadecimal numbers. Mm, the 4 MSB hexadecimals. Nope. This is also a group. I guess each group has, okay, how many semicolons are there? One colons. This is not a semicolon. These are colons. 1, 2, 3, 4, 5. That would mean that there are 6 hexadecimal groups, and you can take any amount, but 6 would never resolve to having 32 in total hexadecimal numbers. So something is messed up, and I will look into the naming convention, how we name it. IPv6 address. Multiple zeros within a group can be compressed to an empty colon block. Communication types. To improve communication efficiency, both IPv4 and IPv6 support different addressing types. So one device can communicate with several devices in a network simultaneously. IPv4 supports one-to-one unicast, one-to-all broadcast, and one-to-many multicast addressing with multi-packet routing. A single packet can be routed to multiple clients. That is cool. Alternatively, IPv6 supports unicast, multicast, and anycast, which is anycast. If I anycast in CDN networks refers to multiple CDN networks having the same IP. Anycast addressing with multi-packet routing. In Anycast, communication data packets are sent from sender the nearest to the nearest of multiple receivers that share the same Anycast address. That makes sense. The nearest is determined by routing protocols that calculate the shortest path or lowest cost to reach the destination, which is the SCRA algorithm. Now, how does IPv6 improve on IPv4? Auto configuration, routing, and security. Okay. Summaries. What is it? Version IP version 4, IP version 6. This uses 32 bits. This one uses 128 bits. Naming represented by 4 pairs of numbers ranging from 0 to 255, 8 lots of 4 character. Okay, there are total 8 lots of 4 hexadecimal characters. Right. So these are 4 hexadecimal characters, 4 hexadecimal characters, a single. Then so this in total is 1, 2, 3, 4, and one missing, 5 and 6. So there should be 2 more lots. Where the fuck are they? Yep, that is sad. Loopback address is this, and loopback address is this, which must have been explained in one of these paragraphs. Okay, now I want to get to IPRFC. Let's see. Internet Protocol R. Oh, shit, it is 791. Why is that so later? Why did it came so later? I want to read the this whole fucking Internet Protocol IP. But I guess before that I should get into the OSI model, right? And then continue to get into this IP protocol. Just for curiosity, what is RFC? Number one, host software. Is it used? That is pretty small. Cute models here. request connection over link 25 terminal. I have a terminal here which sends a request to some host, and that host send a request connection over to 25, and that the other host receives the request and gives it to the other terminal. That that is prehistoric. Well, it is still used in SSH. That is pretty beautiful. A summary of the IMP software. What is RFC number two? Content. Yeah, a summary of the IMP software before link establishment. After link establishment, they have beautiful ASCII diagrams to explain their stuff, which is cool. Which is cool. Pretty cool of them. RFC number two, host software. Number one was also host software. Number three, documentation, conversions, which is shit, that is pretty small. Distribution form. This is the whole content. Shit. The content of the network working group seems to consist of Steve Carroll of Utah, okay, Jeff Rolifson and Will Duvall at SRI, and Steve Crocker and Gerard Deloche at UCLA. Membership is not closed, and this was written in April 1969 when we went to the moon. The year we went to the moon. We went to moon in 60 on the 16th of July, if I remember correctly. Mm, when did Apollo 11 land on moon? 16 July? 20th July. Shit. In 16 July, I guess, 1492, 16th July, Christopher Columbus found America. And did Christopher Columbus discovered the Americas 12th October. August? What the fuck is happening? August is nowhere in my memory that the things happened in August. Expedition he reached on October 12th. Shit. Hmm. Okay. Then nothing happened. Fucking hell. On October 12th. It was on October 12th and 20 July. Okay. Something's got messed up in my brain. Uh, yep. Okay. Now the OSI model. Is there an RFC for it? OSI model. RFC. Let's see. Oh, yeah. RFC number this. Yeah. OSI Internet Management, and that is too white. RFC 1214. RFC 214. Yep. OSI Internet Management Model Information, and that is pretty long. Okay, introduction, addition to the MIB 11 structure of OSI model. I should first get an overview. What is the OSI model? Am I getting into the OSI model? Yes, I am getting into the OSI model. What is a good source? AWS? Yeah, Geeks for Geeks. I don't like Geeks for Geeks due to some reason. What is the OSI model? And I want to turn it into black. Yeah, extensions. Go there and dark mode. Dark mode for all websites. Let's see, add to Chrome. I would like to make my own extension for creating a dark mode. That would be cool. Let's see if this thing works. Yep, it is on. And oh yes, it shit, I didn't even notice it. It is on actually. It is actually on. Remove from Chrome. Remove the other one. Yep. And pin that one. Pin the new one. This one. Yep. What is the OSI model? And does this thing also work for websites which already are in black mode? If it does, and does it work for a website Duolingo for our website with animations? Because I already have an account. Let's see. Yep, it was eyes got lost. And password. Shit, I do not remember the password. Let me log in like that. You can see my email, that doesn't bother me. Yep, it messes up the animation and stuff. But it is much better than how it was for another one that I was using. Yep, this one is much better. Okay, what is the OSI model? The Open Systems Interconnection. Open Systems Interconnection. Open Systems Interconnection. How open systems are interconnected. OSI. Open Systems Interconnection. Systems which are open. This is their interconnection model is a conceptual framework that divides network communications that divides network communications functions into 7 layers. Sending data over a network is complex because various hardware and software technologies must work cohesively cohesively across geographical and political boundaries. Yep. uh, Political boundaries, and the protocol that handles the sending of packets over any boundary is called border border trans BTP, border transmission protocol, border gateway, yes, border gateway protocol, BGP, border gateway protocol. The OSI data model provides a universal language for computer networking. Provides a universal language for computer networking. So diverse technologies can communicate using standard protocols or rules of communication. This line that the OSI model provides a universal language for computer networking. This is pretty much it, right? OSI model provides a universal language for computer networking, and it is a conceptual framework. These are important phrases. So, diverse technologies can communicate using standard protocols or rules of communication. Every technology in a specific layer must provide certain capabilities. Yes, it is a conceptual model, and according to this model, protocols are designed. Yep. So this is not a set of protocols. This just defines if you are making a protocol adhering to the OSI conceptual model, then uh, these are the layers in that model. And if you are making any protocol, then this specific layer for one of these specific layers, then this is what this layer should do, and why should you follow this model, because you are not designing the whole system. It is very complex to design the whole system. So just so you will probably be working on a little part of the whole communication network system. So if you have a standard, then it makes interconnection of those different technologies made independently by different groups able to communicate with each other if they are all adhering to the OSI conceptual model, right? It provides a universal language. Every technology in a specific layer must provide certain capabilities and perform specific functions to be useful in networking. Technologies in the higher layers benefit from abstractions as they use lowercase lower lower level technologies without having to worry about underlying implementation details. Yep, black box. Why is the OSI model important? The layers of the OSI, open systems interconnection, OSI, open systems interconnection model encapsulate every type of network communication across, right? The layers of the OSI, open systems interconnection model encapsulates every type of network communication across both software and hardware components. Like, that is crazy, hardware components. The model was designed to allow two standalone systems to communicate via standardized interfaces or protocols based on the current layer of operation. The benefits of the OSI model are given next. Next, shared understanding of complex system. Yep, we humans are stupid and too stupid to deal with any complex system at the full scale. So what we generally do is deal with only a small part of the whole system. And if you are only dealing with a small part of a very big system, then you need standards for those different parts to be able to communicate with each other and share data. And that's where things like the OSI model, open systems interconnection model, come into play to standardize things, right? So other so people can have a common language of communication. Engineers can use the OSM model to organize and model complex network system architectures. They can separate the operating layer of each system component according to its main functionality. The ability to decompose a system into smaller and manageable parts via abstraction makes it easier for people to conceptualize it as a whole. Faster research and development. It's because you exactly know what standard you are following. So you are not inventing, yes, you are not inventing everything thing from, you are not you. Okay, so faster research and development. What I think this means is that you are not even inventing what you want to invent. You already know what you want to invent. You are just inventing a way to invent it. That is a good explanation, I suppose. With the OSI reference model, engineers can understand their work better. They know which technology layer or layers they are developing for when they create new network systems that need to communicate with each other. Engineers can develop network systems and take advantage of a series of repeatable processes and protocols. Um, Paris, Pirate Software, Mr. Thor himself is live. Engineers can develop network systems and take advantage of a series of repeatable processes and protocols. Someday I would like to break up the OSI system, and it would be really cool if I were able to come up with a much better system than this. Well, this system has been in play for over like half a century, but and it still works. So there must be something good. Flexible standardization. Flexible standardization. That is oxymoron. Flexible standardization. Okay, the main function of a layer is standardized. A layer takes a specific input format and spits out a specific output format that is standardized. But how the black box, the layer internals of the layers of that particular layer works is flexible. So, flexible standardization. The OSI model does not specify the protocols to use between layers, but rather the tasks that protocols perform. Yep, the tasks that they perform, not how they perform it. It standardizes network communication development so people can rapidly understand, build, and decompose highly complex systems all without prior knowledge of the system. It also abstracts details so engineers don't require the understanding of every aspect of the model. In modern applications, the lower levels of Networking and protocols are abstracted away to simplify system design and development. The following image shows how the OSI model is used in modern application development. Yep. Open Systems Communication OSI model and OSI model applied on IoT Internet Protocol. Layers. First layer is physical layer. Fog, cloud, big data, business value. Due to some reason, the 2001 Space Odyssey opening music is going on in my head. Application layer is at the top. Okay, that I would guess is like Chrome or something. Chrome. Uh, my mouse is not working. Now it is working, and yesterday we went through how it actually works. Physical layer at the bottom, that is layer 1. Things, layer 1. Devices. Oh, okay, it consists of things which are, let me zoom in so you guys can see. Things, layer 1, which has devices, sensors, controllers. Yes, controllers, sensors, which convert physical signal into electrical signals, and devices. Devices, what are devices? Right, that is a very abstract blanket term to sensors are also devices, controllers are also devices, and then extra, etc. Data link layer above the device layer. Devices convert physical signals like Wi-Fi into electrical signals, right? So I got physical to electrical. That is the thing that the physical layer does. Now, data link layer, connectivity, edge computing, edge computing, CDN, CDN technology, edge computing uses CDN technology. Layer 2, communications, protocols, networks, Wi-Fi, telecom. Data link, connectivity and edge computing. Protocols, networks, Wi-Fi, telecom. Okay, Wi-Fi is a device layer thing, device one thing, layer one thing, right? Wi-Fi is a physical thing, Wi-Fi, physical. And network protocol is not, Wi-Fi does not belong in here, I suppose, right? Communication, protocol, connectivity. What I think this layer does is it links data. That is, my sensor received some data or my NIC. Wait a minute. And that is horrible. My screen has been stuck and you guys weren't able to see anything. That is pretty horrible. I, I was like thinking in the middle that maybe I should check, but I was getting into stuff and I didn't want it to steer away. So, but yeah, now it is here and now you guys can see. And this arrangement is fucked up. This should go there, this should go there, this should go there. Yeah. Now this is standardized. Yep, data link layer, I suppose, helps, uh, it specifies when you use a USB to connect two computers. Okay, that is a very broad thing. When transfer of data happens from a NIC chip, network interface controller chip, to anything that utilizes it on the other end. The network layer, global infrastructure, cloud infrastructure, public, private, hybrid, transport layer, data ingestion layer, presentation layer, application layer. Custom application built using data things data. Okay, that I do not understand it. Yep, there are explanations for them below. And I also have a pretty good book which should help me understand all of this. And that is called Networking, a Top-Down Approach. A top-down approach, yep. Com- Computer Networking, a Top-Down Approach. Jim Koros. No, that is not the. I thought the book that I am thinking about, which is in my head, is written by two people, not a single man. Yep, this one is written by two people. And is this? Nope, this is not the one. Computer networking, a top-down approach, the latest edition. Yep, this is the latest edition, and yep, this is the book. This is the exact book that the exact picture that I have in my mind for the book. And yes, this is Gulag Archipelago, Stalin, um, first or full biography, and the rise and fall of the Third Reich. I only have two left in stock. That is crazy. Huh, Stalin book that costs 1,000 rupees and is 640 pages long. And Metamorphosis Kafka. Oh shit, that is someone else, not Kafka. Shit, this one is a Hobbit. I'm getting distracted and should get back just after seeing how this book looks. Right. In the path of conquest, Alexander the Great. That is a pretty. Okay, now focus. The operating system, the open system interconnection OSI model. What is happening on the right side of the screen when I'm selecting? The OSI model was developed by International Organization for Standardization, iOS, and others in the late 1970s. It was published in its first form in 1984 as OSI is 7498, with the current version being ISO. Okay, ISO is International Organization for Standards, ISO. Right, that makes sense. Current is this. The seven layers of the model are given next. Physical layer. The physical layer refers to the physical communication medium and the technologies to transmit data across that medium. At the core, data communication is the transfer of digital and electronic signals through various physical channels like fiber optics, cables, copper, cabling, and air. Air means air, do they mean air means sound, or are they referring to Wi-Fi as air? And in that case, they should have written EM waves, not air. Air is not the medium in when you we are using Wi-Fi. Or, yep. The physical layer includes standards for technologies and metrics closely related with channels such as Bluetooth, NFC, NFCs, non-fungible characters, physical related with the channels such as Bluetooth, NFCs, and data transmission speeds. Data link layer. The data link layer refers to the technologies used to connect two machines across a network where the physical layer already exists. Okay. Right. This is not working. This is not working. This is actually not working. Reading about the OS, reading theory on a stream is not working for me because when I am reading and learning, I have this is not the way that I want to do this. In on my stream, I want to actually get things done. That is why I started, and fucking hell, it is stuck again due to some reason. Yes, in a stream, I do not. want to just read theory, and in the stream I want to get stuff done. That is why I started to stream. So I'm not getting stuff done. I am reading theory, and that is not what I started with. That is not the vision that I started doing this. Right. So I will stop reading theory. I will read theory. Uh, the only theory that I will be reading on stream would be the one that I am actually one requiring during getting stuff done part, or if I am doing any course, if I'm doing any course on the stream, that is also the time that I will be reading. For getting stuff done part, I haven't actually gotten any stuff done in this except making a socket program in C, and yeah, socket program from both client side and server side in C, which is not good. So Minecraft in C++. So for the getting stuff done part, I am now going to get stuff done. And the goal for this was to make a chatting app, to make an app that would display my live chat. Actually, let me draw some things. So final live chat. Yep, that is the main final target. To get there, I have to write a program that would take in chats from YouTube and print them on the terminal. So right, a program, a program PR that would, what is this supposed to do? Its task is to get chat from um, live chat, get live chat from YouTube and put it onto the terminal so that I can see it, see the live chats, right? And now this part, getting live chat from YouTube, that part requires a few things. Um, that requires for me to write a program, let's say called get chat. It is not get chat. Yeah, chat. Chat is a good word, generally accepted word for live chat. Yeah, I'm explaining gravity with gravity thing. Get chat. This function will hit the YouTube API over HTTPS to get some chat, and that API I don't even have to get into the detail, or I don't even know. I don't know how this processes stuff, and this will return the chats. Well, this will return quite a few other things too, but mainly I will extract the chats, and those chats I will send to this program, which will put them into the terminal. Right. And this part, sending an HTTPS request to YouTube, is a hassle. It requires a few things. First, it has to go to a certain URL over on the YouTube side. I need a specific URL, and that, and to determine that URL, I will go into the YouTube APIs documentation and see the resource that I need, and then specify the field and the other specification which I have to write to get the chat, right? And with URL, I need some token, because due to some reason YouTube wants to know that who is the person who is getting the chat. So these are the two things that I need. And yep, one more thing that is credentials. Credential IALS, which is just a key, and which is just a string which I need. And how is a token different from credentials? Credentials belong to the program who is sending the request to know which account is sending the request. And token is an OAuth thing which specifies a resource allocation, which gives um, the right to access resources. So through key, I know YouTube will know who is there, who is sending the request, and through token, YouTube will know what are the things that they can access, uh, what are the things that they can access, privileges, what are the privileges that they can access. Right? So getting the URL part, determining what the URL will be is easy, right? So these are the three things which I need to send a YouTube HTTP request to YouTube URL, and second, a key, which is also pretty easy. I already have it. And third is a token, which requires much more work. URL is easy, which I can determine after going through the docs. And key is I can just get from Google, which is pretty easy. There is a Google page which can give me the key. But getting the token is a hassle. It requires implementing OAuth, OAuth, and I have to understand the OAuth flow, which I not fully, but which I get in some way. That is, in an OAuth flow, there is a there are three players in an OAuth flow. There is a client in an OAuth flow. O A U T H. My writing has gotten better. And there is a client, then there is a user, which are not the same. Client, and then there is a user, and then there is a authentication server or resource server. Like auth server and wait a minute. Auth server and resource resource server. And I'll be right back. Just wait a minute. And the screen is not stuck, which is amazing. Now, in an OAuth, let me write all of this in a separate place. Get it down here and get OAuth down here and get all of this. below shit. Yep, get all of this below. Now, there is a user, there is a client, there is this is the whole OAuth process, and this is how it works. Um, yep. Uh, shit. Yeah. There are mainly three things. Yes, I have written four, but there are mainly three things. This is the whole OAuth client flow. These are like at the same place, can be considered the same under the same thing, right? So, a client is a program, generally a program. Yes, these are all programs which handle different things, which is a program. And let's say user is a person. Let's call her Alice. Not, no, not, I don't want to go the conventional path. Let's call that person Cube, Kub, Cube. Yep. So Cube wants to go to the program. And what is the program? Program is a service which can which can print photos for Cube. Right. Photo printer. Photo printer service. Right. And now Cube wants to print photos which are in Cube's G drive. And how does Cube do that? Either Cube can go to his G drive and download the photos, upload them onto the program, and then the program will print them. Or Cube can give direct access to the program, to the program, photo printer program, to his Google Drive, so that the program itself can get photos from Google. And for that, how does that happen securely? That happens securely using the OAuth flow. What is OAuth flow? OAuth flow is just like a protocol which has some specifications which guarantees security and pure communication. And so these are just protocols through which different things can talk to each other. So here, resource server, this resource server has the photos, photos for G drive of Cube's resource server, which has the G drive photos. Now, Cube wants the client to get access to these photos. How does that happen? Uh, right, how does that happen? This happens when client gives yes, client has to have for the client, first the client has to have a Gmail account, which they can use to get a key, which I specified earlier that they need a key to get a key. And second, and this is an OAuth key, and this key would specify who the client is in the whole flow. And with this key, they can make they can tell Google that at some points there would be times when they want to access G drive for people's G drive photos. Yep, photos. They can tell Google that at there will be times when they will need access to people's G drive photos. So they can specify the specific things which they need access to, and make tell Google that at times you will be needing access to people's G Drive photos, and then Google will return them a link. Third thing, a URL, which this URL comes from Google in our case, because we want access to G Drive photos, and if we want access to someone's GitHub name or something, then GitHub will send them this link. And how does that happen? They go to the OAuth server and with their key, and they tell that they want to get access to someone's G Drive photos. Then the auth server returns them this link. And what do is they send this link, they redirect the user to this link. Now, the user, when redirected to this link which was given to them by the server, which in our case is Google, the user goes to a page which lists their Google IDs and stuff on the right, and which the page which you have must have seen at places like where can I log in, which where I am probably not logged in right now. Maybe lead code. Yep, I am logged in there. So the page which comes, which asks you which is the Gmail ID with which you want to, um, with which you want to log in and stuff. So this happens, and after selecting the Gmail ID, the user is automatically by Google. But this whole page, we don't have to. This program does not care about how this thing works. We will, after this, talk about how things look from different people's perspective, from the client side, from the user side, and from the Google side, how things look from each other's perspective. Uh, and so here, after this, the cube is redirected to another page, which states the accesses, accesses, the accesses or the permissions. Eyewitness. This new page specifies the access and the permissions which were specified here in step 2 by the client. So this here Google is asking the user, do you want to give permission, yes or no, for this Gmail which you selected in this page? Do you want to give permission or not? The user, let's say, says yes. In that case, the user, in that case, the page closes, right? This page disappears and closes, and this thing happens. This thing is recorded by the auth server. Now, when when our client sent uh, their key and the access that they want to the auth server to get this URL, the auth server, no, there was an additional thing which they sent there, which was a redirect URL. There was a redirect URL which was also given to them. And what happens is that after getting the confirmation from the user, after recording the confirmation, the auth server takes in a token. It generates a token. The auth server generates a token and sends it to the redirection URL, which was given to the auth server by the client. And that at that redirection URL, our client is listening for this token. There is a separate program server listening for a token on that redirect URL. Now, after getting the token, which like directly the auth server does not directly send a token. It generally sends a code which you will send again to the auth server and get back a token. But let's just here assume that it directly sends a token. After getting the token, after getting the token, our user is well back on the page because this page closed and our client has the token. Now it has all the things that it needs. It has the token. It the workflow, you can consider it completed. I have the token, right? I have the token. And what are the resources? Resources in this case are the chats. And what is the program? The program is this get chat function, which wants to get chats. Chats are the resources. And who is the user? The user is me, who owns the chat, who is live streaming currently. So after getting all of these things, the get chat function can make its can make its can make its request to the YouTube API and get back the chats and return the chats to the program, and the program will print the chats to the terminal. Now, in the OAuth flow, OAuth flow, I want to make some things more clear. We have three things. First, we have a user. We also have second a client, 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 and auth server, auth slash resource. You shit. My writing is slow. A resource server. Now I want to write about things from each of their perspective. First, let's say, yeah, a client is just a program. Program, yep. The user wants to log in. So this is pretty slow. Should I go to typing? But I want to improve my writing. So and this is how I'm going to conduct things. The user wants to, let's say, log in, which is a very specific thing. It does not always wants to log in, right? The user wants to log in. How does that work? In that case, this doesn't do anything, and this doesn't do anything. At this point, the user just wants to log in. The user then specifies the auth server or the company or the credentials which they want to use to log in. Let's say they say that they want to log into this program, this client program. Let's say this is lead code. They want to log into lead code using their Google email. So at this point, the user tells lead code that they want to log in to Google. Then lead code, what does it do? It does these things. This lead code already has its own Gmail account and a key, and it already has uh, specifications for what they want to access. So at that point, lead code, along with its key plus resources like a specification for resources which they want to get access to resources list would be a better thing to write with their resource list, and this they add a redirection URL. plus plus re and direction. Yeah, the spelling is wrong, but that is fine. You redirection URL. They send a request to the auth server, to auth server, which is Google in this case. And yeah, and that is captured by the auth server. What does the auth server do? The auth server gives in return a URL, to which URL, let's call this URL number one to the client. The client in the next step, in the next step, as I am writing them in parallel, the client gets the URL, it uh, gets URL. Yep. And the client gets URL and redirects user slash redirects user, and the user gets redirected. Redirected. The user gets redirected. The client, the user gets redirected, and the client redirects, and the auth server, what does it do? The page to which the user got redirected, it handles that page, handles a redirection page, redirection page. It handles the redirection page. In the next step, the user logs into whatever the service wants, which they specified here. Wait. Yep, I am back, and it was a call from a company to hire me for some online stuff and shit. But now, logs into Google. Yep. They log into Google and give permission. Not give permission. They don't exactly give permission, but they what would be a better technical word? Give consent. Yep. Well, that is just a fancy way to say give permission. Yeah, so they just give permission. They give permission. They give permission to client. IENT. The user gives permission to client, and nothing happens on the client side. It is just waiting, uh, waits or listens. Listens is a more technical term. Since is a better term. Yep. They are the client program just listens on the redirect redirect URL which it provided in this case. This redirection URL. TI1 redirection URL. It is listening on the redirection URL which they provided in that case, and the auth server records response. Yep, it records a response, and then in next case, and this login screen vanishes, and vanishes, and the client uh, gets a request, gets a yeah, since it is an HTTP server listening on a specific URL on a specific port, it gets a request. Yes, that is how it is called. It gets a request which contains a code. Yep, it contains a code, and yeah, I guess that is it. That is all that it contains. It contains a code which was generated by the auth server. So the auth server is the one who the sends the code. Now, in the next step, what happens is nothing happens on the user side, but this the client side gets wants to get a resources. Now it has the token, so the client sends a request to resource server, sends a request to resource server, not the auth server. Re Wait, fucking hell! It sends a request to auth server first, because it has to convert the code that it got into a token. So to do that, it sends a request back to the auth server. Sends request to auth server plus with the code which is just a string that it got code, and the auth server sends back a token. Sends back. No, it does not send back a token in this step. I should better say, because I'm the way that I'm writing these, it records. It records the code that it just got and authenticates that who does this code belong to. And in the next step, the client gets a URL after sending it, gets a token, not a URL, gets a token back, and the auth server is the one who sends the token. Yeah, yep, the auth server sends the token, and the client gets the token. Now the client sends a request to, this time, to the resource server. Yep, resource server. What does it include in the request? In the request, it includes the token and the stuff that it wants. It lists the resources that it wants, and the client server just receives a request. It receives REQU. Yep, it just receives a request, and in the next step, the resource server sends a request, sends back the resources. back the resources which were listed in this request, and this records the resources. This records the resource, and yep, and at that point, when the client has the user's resources, which is their name and name plus email and whatever the stuff was that was listed in the resources list. When they have that, they store some part of it in some way in in their own database and create a new user. So they just, and in the next step, they create user, and in that step, the user um, gets logged in or registered, logged in. That is how the whole OAuth flow works. Now, what is the part that I am stuck in? Yep, what are these things? Yeah, that is some other stuff. What is the part in this whole thing that I am stuck in? The part that I am stuck in is this, making a redirection URL. I want to create a redirection URL that should be accessible by the OAuth server. That is, that the redirection URL that I create should be globally accessible. Yep, and first it needs here redirection. Wait, it is just so fun to write here like this. It takes time, but yeah, it gives me time to think about things thoroughly while I'm writing. Redirection URL, it needs to be two things. It needs to be global, that is, the Google server should be able to reach it, and it needs to be static, so that it is same throughout. Because if I were to send my IP address plus the port number, which generally is the URL, uniform resource locator, then it won't work after a while because my ISP keeps changing my IP address for security reasons. So I have to first make it global and make it static. To make it global, I have got into like, what the fuck did I even got into? In the past 3 to 4 days, I have been streaming about, I have been learning about networking, about DNS servers, DHCP, CDNs, and then yesterday about NICs, network interface controllers, and just other stuffs, NAT, which is network address translation, which was introduced after 2011 when the IPv4 uh, when all the available IPv4 addresses were exhausted. Then network interface tables came in, and DHCP server responds with configures a device's default gateway, their subnet mask, their DNS server, and their, of course, IP address. Now, to make my this global, how do I do it? How do I make my network global? And this is my 191.6 168.29.1. This is my default gateway. That is the place. Wait, where? Why am I not getting any auto suggestion? I usually do get auto suggestion, but shit. 192 and stuff. And this is my default gateway. Yep, there's the auto suggestion. This is my default gateway, and I can log into my router like this and change some settings in there. Let's explore. I have two goals: to make it global and static. Static will not be handled by my router. That will be handled by me using a DDNS service. DDNS service, that is a dynamic. Nah, that is wrong. That is wrong. The spelling is wrong. Shit. Cannot even spell, and I am in a college. Dynamic. That is dynamic DNS. Dynamic domain name service. That is dynamic DNS. And to make this global, I have to do some things. DHCP state for okay. Let's go through the router settings to get a feel of how things are working. Uptime, it has been up for 5 days. Yep, no, it was 5 days when I stopped my server and restarted it again. Okay, and in LAN information, which is the local area network information, this is the MAC address for the router that I am accessing right now. This is my default gateway, the address for my router. Okay, this is also the default gateway. So if I were to wait, nope, this is not the default gateway. This is the DHCP server 552.552.550. This is the address for the DHCP server. Yep, I do not send. I cannot send a request like that direct from my browser to a DHCP server, right? Yep, but can I send a curl request there? Nope, nope. Ping. I guess ping. I don't know. I don't even know what is the difference between curl and ping. Timeout, timeout. Okay, I cannot send direct request to DHCP server, but I can send request to my default gateway 168, 29, 1. I guess it was. It's not working in this. 168, 192, 168, 291. I do get something, and this HTML that I got is for this page, this default page. If I do this 192, 168, 29, 1, and yep, I am getting bytes, consistent data from this. And after a while, this will stop because I would have gotten all of this data. Right. And what is enabled? DHCP4 is enabled. DHCP4, wait, IPv4 DHCP relay is disabled. Okay, I don't know what that means. And then DHCP for IPv6 is enabled. That is cool. WAN information. I cannot change. This is just information. This is status. Status cannot be changed from status. That is like a read-only thing. MAC address. This is the MAC address for WAN, which is like the same. IPv4 address and DHCP server address. Right. So why is the MAC? Well, MAC address has to be the same, I guess, in both the cases. This is the MAC address here, 9A75 at the end, and I should 9A76 at the end. MAC address is different for LAN and for WAN. Alright. For LAN and for WAN, MAC address is different. Even the IPv4 and IPv6 addresses are different. Is that I guess makes sense because in LAN I am, yes, if I want to access my router when I am connected to the local area network, then I will use the LAN IP, right? And if I want to access my router from the internet when I'm not connected directly in the local area network of the router, then I will use WAN IP. Like this should get me to this. Yep, because I am connected to the local area network. Yep. NAT network address table is enabled for IPv4 only. In IPv6, I'm not applying the NAT network because IPv6 is basically inexhaustible. Then IPv4 connection. Mhm. IPv4 connection type is DHCP automatic. IPv6 connection type DHCP stateful. Stateful. I'll look into what automatic and stateful mean. And is my router connected and through the IPv6 protocol? Yep. Is it connected through the IPv4 protocol to the internet? Yes, it is connected in both the ways. And gateway is this for IPv4 and IPv6, right? If I want to access from in here, right? And primary DNSs for both the cases. Okay, and there are no secondary DNSs, only the primary ones. DNS for this is this, for this, for IPv6 is this. Now, wireless information. That is an IC chip. Wireless LAN 1 is 2.4 gigahertz, and this is the mode, and channel is 1. I do not understand what channel means, and I do not understand what is this mode. This must be the protocol that they are using. And available access points, SSIDs. What is ID? Full form, service set identifier. ID. Okay, service set security is these. Authentication is okay. So I have not just 2.4 gigahertz and 5 gigahertz connection. I can have multiple. I have one, two, three, four other connections too, which are currently disabled. That is messed up. Let's say I'll try to connect to them using my phone. Yep, one, two, three, four. These four are off. They are not working. Right. And device statistics. Okay, that is cool. LAN clients. These are the clients that are connected, and MAC addresses and stuff. WAN clients, mesh network, mesh to network, LAN, local area network. This is the configuration. That is that what will the DHCP response consist of? IP address, TCP IP setup. This is the IP address. I can change it. I can change the default gateway. I can change the subnet mask from right here. I can change the DHCP mode. DHCP mode is DHCP server. Okay. Start IP address is this. End IP address for the subnet is this, right? And DNS servers. What is the DNS server I'm using? DNS proxy. I don't know what that means. Lease time is 24 hours. For reserved IPs. Yes, why would I need reserved IPs? Only for IPv4 because I am using a NAT table. That is why I might use reserved IPs in IPv4. And why do I not need reserved IP in IPv6? Because in IPv6 I am not using a NAT table. Therefore, one IPv6 address only maps to one device. Right. Yeah. And yeah, one IPv6 address only maps to one device. That makes sense. And yes, stateful and stateless, two ways, and I will have to see what stateful and stateless means. Now, network wireless. These are off. Can I make them enable? Can I enable them? That would be crazy. That is fucking crazy. Actually, fucking crazy. I have multiple connections. Fucking hell. Wait, name. Name is 05. Okay. Maximum clients is 1. Okay. Shit. Let me actually do it. WLAN partition. What is WLAN? WLAN full form. Wireless local area network. Okay. WLAN partition. What does WLAN partition? What is WLAN partition? WLAN partition is a feature that separates a wireless band from the rest of the network. It can be used to isolate wireless and wired communication for security purposes. Okay, if I were to do this, then I can have a single connection for my laptop and my phone through a single channel. That would be cool, actually. AP name, right? And let me enable it. I can just enable it like that. And if I were to, okay, I'm back. Seems like I'm getting connectivity. Yes, I am getting connectivity. Yes, I am getting some connectivity. I am back again, and fucking hell, let me check my Wi-Fi. How that is looking. Mm, It looks just fine. Yes, I can see that I'm connected to the network and to a low bandwidth connector, and I hope my stream is visible. Let me check from my phone. My stream should be visible. Let me check. It is still loading here. So let me check on my phone if my stream is visible. It must have stopped in the middle, right? And which is actually fucking crazy. Let me see. Yep, it is live and working. It seems to be live and it is working. I'll just put it here so that oh shit, someone liked my stream. Let me see the live chat. There is no live chat and someone liked my stream, which is not true, and therefore it is pretty good. If I were to ping it again, yes, it is working. It is stopped for a while and it is still loading. If I were to make another connection to my default gateway, what will happen then? Will I get logged out from the first one? Let's see, admin and login, digital loading and stuff. Maximum of 50 clients are supported for radio 2, and radio 2 it is written here. Maximum 50 clients are supported. Continue configuration. Forced login. An active session already exists for the admin user. Yep, forced login. What does that mean? Shit, it is loading. Yes, I have forced login. That is 2 connections with the same ID. I can make a different person, a different user other than client, which would be cool. Wireless. Yo, I see it. I see it in geo number 2. And right, and after that, let me try to connect my phone with geo 2. And I would need to know what the password for geo 2 is. How can I see the password? Channel is spacing, right? That must be something. What is the password? Password. Authentication SPK. Geo 2. Edit. I must get in. Yep, WBA password. and haha, mm, SSID name. Let me private network. I'm right. I'm writing this as private network on a live stream. Radius. I can. This is my own. This is my own security. I can. It can be open or WPA2 or broadcast SSID. This is my own thing. Shit, that is crazy. The password should be this, which I have written right now, and save. And let's see if I am right now. Only one connection is online. Let me just try to log in anyway. And did I log in? Nope. It says incorrect password, so it has not changed. Mhm. Let me type in the password for the other connections. Nope, it is wrong, which makes sense. It has not changed yet. Yep, it has not changed. I am unable to log in. So while it is happening, I can look into what encryption. Okay, encryption makes sense. Authentication is SPSK. Okay, WPA2 is security. Encryption is CCMP. Okay, what do I want to understand? Yes, hmm, in my Wi-Fi router at home, I have uh, two connections available. One is slower one at 2.4 GHz, and the other other a faster one but lower range at 5 5 GHz. Right. Does this mean that my router has multiple NIC network interface controller chips available inside and thus I can connect I can not connect does not seem like a right word. I can communicate with it using these I can communicate with it using these different NIC using these different interfaces. Right, question mark here. Is your Wi-Fi router likely has multiple NIC chips or a single NIC chip capable of operating at both of these bands? That is also fucking amazing. Dual band capability. Your router supports both 2.4 longer range, lower speed, and 5 GHz, which is shorter range and higher speed. It either has two separate radio trans receivers, each acting as NIC for this for 2.4 and for 5 GHz, or it has a single dual band capable NIC that can operate on both frequencies. Multiple interfaces for communication. Since the router broadcasts two different SSID Wi-Fi router names. SSIDs. Guess what is SSID? Each band effectively acts as a separate interface for communication. If your device connects to 2.4, it communicates via 2.4 GHz interface, and if it connects to 5, it communicates via 5. Simultaneous operation. If your router is a dual band simultaneous, it can handle both 2.4 GHz and 5 GHz connections at the same time, meaning it does have multiple network interfaces internally. Seamless switching. If your device supports band steering, it can dynamically switch between 2.4 GHz and 5 GHz based on signal strength and network congestion, congestion. So in essence, your router does have multiple NICs, whether separate or one with a multi-radio capability that allows communication over bandwidth. Okay. What is SSID? S SSID is different. I'm getting different SSIDs. Let me try to connect now by typing in the password because that loading has been going on for a while and shit, it is taking time, so maybe it might connect now. For Geo 2, it is just taking time. What is SSID? SSID service set identifier is the name of a Wi-Fi network. It's what you see when you scan for available Wi-Fi connections on your phone or laptop. Okay, let me go to the settings and try to connect to that new network, which should say nope. It is just saying Geo 2. It is not saying private network. Private Wi-Fi address is fixed. Rotating off. Join this network. Join this network, it says. Right. Key points about SSID. Unique identifiers a Wi-Fi network. Uniquely identifies a Wi-Fi network. What does Wi-Fi network mean? I guess it means what does Wi-Fi network means? I guess what it means is it is just local area network broadcasted by the router. Your router constantly sends out the SSID so nearby devices can find and connect to it. Okay, can be hidden. Some routers allow you to hide the SSID so it doesn't appear in the list of available networks. Can have multiple SSIDs. Dual band routers have separate SSIDs for all these and this. SSID is changeable by the user. You can rename your SSID in the router's setting. Would you like to know about SSID? SSID. Right, SSID. Let me log into my router. 1.2.168.29.1, which is my default gateway. What was it? 192.168.29.1. Yep. Let's go and log in, a force login because I am already there. Shit, it does not say a force login. That is cool. Wireless LAN security, wireless. Yep, go to wireless. We were exploring wireless AP name. Right, what is the thing that is in? Right, SSID can change, it is changeable. And security is this profile name. Okay, what are the things that can change? Profile name, let's see. What are the things that are changeable? Profile name, that does not change. Okay, SSID can change and other things can change too. Right, and what is the password? I want to see shit. Uh-huh. These are enabled and are being broadcasted. That is okay. And right. Let me see. Can I connect to it now? It should say private network. Nope, it does not say private network. Yep, it does not say private network. Broadcast SSID. Wait, what is the setting in the normal router? Yep, it does broadcast SSID. And security is WP2, CCMP is the encryption, and authentication is PSK. Can I see the password like that? Nope, I cannot see the password like that. Geo3, yes, and access points. Right, status. Okay, the one with the SSID Geo 2 is on, and I was messing up with the one saying AP2. Okay, AP5 is the one that I have to change. AP5, not AP2. Right, right. That is pretty stupid of me. That was pretty stupid. Profile name. Yes, what is the profile name for that? I guess it is AP5. Yep, AP5. AP5 is the one that I enabled. Shit, I am stupid. Edit. Yep, edit this one. Yep, and make this private network. This will be called private network, and here's the password. Yep, yep, and I should be able to connect to it now. It goes down. Fucking hell, whenever I do that, my own connection goes down, and I am connected to it through my phone, which is crazy. And can I see live chat and stuff? And I can actually see live chat, so it is working on my phone, and that is crazy. Let me check the speed for this new thing on my phone. Yep, I am going to fast.com on my phone, and the speed is 27 Mbps, which is normal and stuff. Okay, this is pretty amazing. Yep, the speed is 29 Mbps. That is cool. That is cool. I have established another. I don't know what it is. SSID is a changeable thing, so that is not which distinguishes two networks. Continue, yeah, fucking hell, continue. Close that one. Close the old one, and let's explore this. Go to the network, and in wireless, these are different networks that are online right now. This is what are the things that are changeable about them, that are non-changeable, which associates them to what they are. Profile name. Okay, so profile name. WPS. What is WPS? API1. Security for selected VAP. Mm, yeah. Channel spacing 2040 megahertz. Channel spacing configuration for 2.4 gigahertz. Megahertz. Encryption is AES for AP1, and for AP5 is this, and WPS that I don't know none of this shit. Okay, and right now I am ending the stream, and because like yes, I am ending the stream, and I will get on these things on my own, and we'll get into this, what all of this means, what is actually different between them. And profile name does not seem to be different, like, and the thing that is distinguishing them, what is actually changing here. Access points, right? What are access points in my Wi-Fi router? In the router settings, I am seeing multiple access points. Some are enabled and some are disabled. And does every access point mean a separate NIC chip? An NIC chip which which can be used to connect to the same LAN network under this router. Yes, which can be used to because a single one might face traffic when a lot of users are connected to it. What are access points in your Wi-Fi router settings? Access points, APs. AP number. And there was something called AP number. Yep. AP1, AP2. Yeah, AP name means access point number. APs in a Wi-Fi router are separate wireless interfaces that allow devices to connect to your local network. These can be physical or virtual depending on how your router is designed. Yeah, these can be physical or virtual. That makes sense. Okay, access point. These are wireless access points, and there can be Ethernet is also an access point in that case, and which is just a abstracted term for a network interface, I suppose. Does every access point mean a separate NIC chip? Not necessarily. Your router may have multiple physical NIC chips and network interface controllers. Some high-end routers do have multiple dedicated Wi-Fi chips for different bandwidths and even 6 GHz in newer models. A single NIC running multiple virtual APs. Many modern routers create multiple access points virtually using a single physical NIP per frequency band. In either case, each AP client allows client. Yeah. Why does your router have multiple APs? Yep, that is a good question. Different frequencies. Okay, one AP for 2.4 gigahertz, longer range and lower speed, and one for 5 gigahertz, and maybe one for 6 gigahertz. Guest networks. Some routers support a guest Wi-Fi network, a separate AP that isolates visitors from your main network. Some routers support a guest Wi-Fi network. Okay, all right. Instead of giving out the main password for the main network, you can give them the password for the guest network. Right, that makes sense. That makes sense. Different or for different purposes. Example one for IoT devices. For IoT devices to connect to it to make things separate. Yeah, that makes sense. That actually makes sense. In IP5 edit, and I will change the number of connections. Okay, that does not happen here. That shit, this is going to take eternity. 192, I don't know why this does takes eternity. And did that change everything? Nope, I'm streaming, still streaming. Login. Loading. Please wait and let's see. Yep. And network wireless. I will increase the number of users so that will be cool. Edit Mac filter. I can only allow some certain devices to connect to it. Uh, Profile name is Geo5. Profile name is something right. Uh-huh. Right. Profile name. Yep. And edit. Is this the one where what? Which one is the one where I changed the number of users who can connect to it? Let's make this to 10 users can connect. And what is WAN partition? WLAN partition. I don't know. Did that? Nope. That did not reduce my own. Shit. Nope. That didn't disturb my kbps here. Alright. There is a profile name and this a profile name and a WAN partition. Yes. What is profile name and Maximum of 50 clients are connected. Okay. Guest networks, yep. Mesh or multi SSID support. Some routers allow multiple SSIDs with each of its own access point for different purposes. Example one for IoT, another for normal users. If you have mesh network and networking enabled, extra APs may be managed, controlled to extend your coverage, traffic management, and load balancing. Having multiple APs, especially on different bands, helps spread the load across multiple frequencies. Devices can connect to different APs to reduce congestion on a single AP. Should you enable or disable some APs? If you don't use guest networks, you can disable guest APs to improve security. If you experience Wi-Fi congestion, enabling additional APs, especially on 5 GHz, can help balance the traffic for IoT or legacy devices. Keep 2.4 GHz active is useful as some devices don't support 5 GHz. Your router has multiple APs and okay, okay. And there was something that I read in this mesh. Some routers allow multiple SSIDs, each with its own AP for each SSID with its own AP for different purposes. Example one for IoT and another for normal users. Does this mean that in the IoT will have their own LAN and the normal users will have their own LAN? Okay, and what are the purposes of having different shared? There can be virtual LANs, that is cool. Then different SIDs such as one for IoT devices and another for normal users can be placed into separate LANs. Okay, there can be a virtual LANs. Okay, okay, I want to read this again. Multiple physical NICs might have, yeah, what are the reasons? Different frequencies to distribute different frequencies to make guest networks, might mesh traffic management. Okay, 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 that makes a little sense. Then profile name and what is profile name, and one more thing, what is profile name and what is WLAN, wireless LAN partition. Yes, in my router I see two other things which I don't understand. One is um, profile name and the other is WLAN partition. And is WLAN partition on for any of them? For 2.4 gigahertz, nope, it is off. Maximum clients is 30 there, and for this gigahertz, 5 gigahertz, the maximum clients are 48 and it is off. Uh, partition, which is currently off for all the APs, access points. Let's see. Understanding profile name and WLAN partition in your router setting. Wait, this is, I guess, a standard way. Profile name is a standard way to refer to a single SSID because the SSID name can change, but profile remains the same. Okay. When routers allow different SSIDs to have unique profiles, which can control things like this SSID name and password. Yep, security, frequency band, yeah, to refer to a single, because SSID name can change, so you cannot use that to refer to some access point. So profile name fixes that. WLAN partition currently off. WLAN partition is a setting that controls whether devices connected to the same Wi-Fi network can communicate with each other. Alright, if enabled, devices on the same SSID cannot talk to each other. They can only access the internet. If disabled, which it is by default, devices on the same Wi-Fi can freely communicate. Alright, WLAN partition. They cannot communicate with each other. Alright, if disabled, they can communicate. If enabled, the devices on the same SSID cannot communicate to each other and they can only access the internet. Use cases for enabling WLAN partition. Guest networks prevents guests from accessing other connected devices. Example, printers, shared drivers, and smart TVs. Public Wi-Fi stops users from scanning or attacking other devices on the same network. Other devices on the same network, right? IoT isolation. If IoT devices are on the same SSID as normal devices, enabling WLAN partition ensures they cannot access or spy on your phone or laptop. Why is it off by default? Most home networks don't need this isolation since people want device to talk to each other. Example, file sharing, Chromecast, AirDrop. It usually turned on for security reasons in public or guest networks. What should you do if you want devices on the same network to communicate? Then keep it off, and if you don't want, then keep it on. So, does it mean that that devices under under the same AP can communicate with other devices connected to the same AP, or that devices connected to an AP can communicate to devices connected to another AP. What does WLAN partition actually do? WLAN partition is enabled. When it is enabled, it means that devices connected to the same IP cannot communicate with each other. It does not block communication between different IPs, SSIDs, unless traditional network isolation like WLAN are applied. Alright, they cannot talk to each other, but they can talk to the other LAN devices on the same AP SSID. If WLAN partition is on, devices can connect to the same AP, cannot communicate with each other. Example, two laptops connected to the home Wi-Fi 5G cannot send files to each other via local networks. Sharing a Chromecast and phone on the same Wi-Fi won't work together. If WLAN is off, by default they can communicate. Second case, devices connected on different IPs. WLAN partition does not block communication between devices on different SSIDs API unless the router has VLAN or firewall rules enabled. Example, I'll have this. Alright. I have enabled another access point in my router, right? And in profiles, WPS, what is WPS and what is channel spacing and other stuff, which I will get into the next in next stream, or I will do it learn about it on my own locally. For now, what I want to know is, does enabling different type okay no the total throughput for my router is fixed, and when throughput for my router uh, to the internet is fixed, right? Which depends on the medium used by it to connect to the internet, which in my case is fiber. Now, if the to uh, uh, let's say uh, this fiber, let's say that is a, 1,000 Mbps. That is the total throughput for my Wi-Fi through fiber to the internet. Now, let's say that I have a connection that allows 50 Mbps. Right, I have a connection which is 50 Mbps. And so 20 users can connect to the router without problem, and each will get a 50 Mbps connection, right? But if the number of users increases above that, then I then each will get a lower connection speed. Huh? Question mark. Yes, exactly. Total internet bandwidth is fixed as 1000 Mbps since it depends on your fiber connection. How bandwidth is shared among users. If you have 20 users, each getting 50 Mbps, total usage is 1000. No issues since this matches your total available bandwidth. If the number of users increases beyond 20, example 25 users, the router has to distribute the 1000 Mbps among all connected users instead of each getting 50. They get 1000 divided by 25, that is for 40 Mbps. If even more users connect, let's say 50, then each will get 20. Everyone's internet slows down. If some users use more bandwidth than others, if they are using streaming 4K video or downloading large files, they consume more bandwidth. Other users will get even less speed since the total is still limited to 1,000. Some users have uh, quality of service settings to manage bandwidth fairly. Does it matter which AP SID I connect to? No, all APs share the same internet bandwidth. Ah, okay. Even if users connected to different SSIDs, these they still share the same 1000 MB internet connection. Yeah, okay. How to manage this a limit per user bandwidth in router settings if supported. Use quality of service to prioritize critical applications. Okay, work over video call streaming. If you need more bandwidth, consider upgrading your fiber plan. And if I am using, if only one user is connected to the router, he will get only 50 Mbps speed since that is the Wi-Fi plan. Even though uh, theoretically we can get 1,000 Mbps. Right, right. Let's see. Not necessarily. If only one user is connected, the actual speed depends on IP's plan per user. If your ISP internet service provider enforces a per user speed cap of 50 Mbps, then yes, that user will get only 50 Mbps, even if no one else is using the network. Some ISPs do ensure a fair usage. Your router's Wi-Fi bandwidth limitations. If your router has been configured to limit individual connection to 50 Mbps, then the router won't exceed Wi-Fi signal and technology. If you are using Wi-Fi 5G or Wi-Fi 6G, the theoretical max limit of the connection might be much higher, but your ISP still controls the actual limit. No ISP limit exceed full bandwidth. If no ISP limit exists, then full bandwidth. If your ISP does not import a limit and can only use a connection, they and use the full 1000 Mbps for whatever max speed the router supports. The only limit would be the Wi-Fi standard or Ethernet cable, which is over 1 GB for Ethernet. Right. The limit on the network is put on by the ISP, which depends on the Wi-Fi plan that I have subscribed to? Question mark. Yes, exactly. The speed limit on your experience is primarily controlled by your ISP based on the internet plan that you have subscribed to. So 192.168.29.1. Right, that is correct. And shit, I'm not getting any auto password suggestion one night. Go there again and shit, no, 192 and yep, A91. Yep, auto suggestion and let's go. Internet gateway. Right, and can I fix stuff? WBS and NAT classical routing. V6 static LAN multicast. Static routes. I don't know what the fuck that means. No per user limit, total bandwidth versus individual speed. You are total internet speed is this, and but you are only allowed 50. I will get 50. In 2 years, to can use 100. It's fast.com are there. All right. Okay, that makes sense, and that concludes today's streams. Or shit, if I can just stream for 2 more minutes, that would make 2.5 hour stream. In that case, I will stream for 2 more minutes, and I'll go into my router settings and explore some stuff. Let's see. Login. Now I have created an access point, which is pretty cool. I can see it here. Private network. Yep, right here. It says private network, and it is 5G. Administration, security, advanced network routing. Routing mode, NAT, and classical routing. IV, IP before this subnet mask edit. Let's see what this means. This is of LAN multicast, multicast. Same signal would be sent to all of them. Destination is every device that has this something. This and subnet mask is this. Right. Right. Every device that has something like this. Go work. Where to send it? Wait, network. Okay, spread it on the local network and gateway. What is that gateway? What do I put in the gateway? No, metric 15. IPv6 static. Let's see. Static routes and add new. Right, name. Let me say I will call it multicast. I will make it active, and destination would be what is if config en0. If config en0 and grep. Yep. Secured scope. This. No. This one. This is dynamic due to some reason. I don't know. Prefix length is 128. This one. Put this in there, and what is going prefix length? It was said 128. 28. Internet. Local. Broadcast to local. Gateway. What is the gateway for IPv6? Yeah, I saw it on in the router settings, right? Um, which is, I guess this is it. This is the gateway. Uh-huh. No, that does not look like it. Uh, huh? Nope, that is not it. The default gateway. Oh shit. Wait. No, this it was in the dashboard. It was there. If I remember correctly, the default gateway for IPv6. Uh, MAC address, LAN, WAN, yep, WAN, IPv4, and IPv6. Alright, which is okay. That 128 at the end says is telling me the prefix. Alright, and if I go there, shit, why don't I see anything? If I go into this, here the prefix is 64. That does not do anything. Mm-hmm. Right. Um, where am I making this available? Okay, yeah, I should use this one. This one. Yeah. Let's see if this one works. I don't know what the fuck I'm doing, but still, let's see. Static routes. Add a new static route for IPv6. Gateway is this, and prefix length for it is 64. And I want to broadcast to local. And literally, I don't know what I'm saying. Multicast. It will be called multicast. Metric. I don't know. 10. Please enter valid IPv6 address in the last two octets. Okay. Okay. Hell. Okay. I am doing this, and that is the end of the stream for today. Well,